Okay, hello class. Regarding to our last session discussion, here we want to continue our highway capacity analysis based on our last session. If you remember, in the last session we defined many kind of different sorts of highway capacity analysis and measurement, such as level of service, MOE, or measure of effectiveness, capacity, volume over the capacity, free flow speed, and many other things. Also, explain, we discuss about the different type of the facility we have interrupted and uninterrupted, if you remember. And also we discuss about the factors which affecting the level of service, which affecting the traffic flow, like lane width, number of the lane, train level, mountainous level, roading level, or other factors like heavy vehicle factors or even population factor. So we went through all these factors which possibly can affect the highway capacity. Now we want to go through these measurements, this time by exactly calculating these values. If you remember, as we mentioned in the last session, level of service is not a value. Level of service is a range. Okay, so for calculating the level of service, we need a range. We usually use density, maximum density of a free flow speed or a traffic flow is the limitation for the level of service. So maximum density for level of service A is 12. It means that between 1 to 12 or 0 to 12, the density between 0 to 12 we consider as level of service A. Between 12 and 20 we consider as level of service B. Between 20 to 30 we consider as level of service C, and so on. It means that, for example, if in a problem we mentioned that the maximum density is like 18, so you know we are talking about level of service B, because 18 is more than 12 and less than 20. So any number, for example, after 30, so is not anymore level of service C. If it's, let's say, like 38, it is level of service D. All right. So the density is like boundary between. We use the density for like boundary between the different kind of level of service. So here is very useful table that we will use it frequently, especially in final exam. If we have such question like calculating the level of service, analyzing the free flow speed, like that, so this table is very useful. So basically in the final exam or in given problem, the S speed is like given information, always is given information. So if we said, let's say the design speed is 60, so you know you have to come to this part of the table, all right? So if we say, let's say 70, you have to come to this part of the table, obviously. So this table give us simply so many information. For example, according to given speed like 70, so we can see here, for example, for level of service B, the maximum speed, actually the minimum speed should be like 57 mile per hour, and the other valuable parameter here is V over C, which is volume over capacity. This one would be used so frequently in many problems, okay? And also we have MSF, which stands for maximum service flow, right? So maximum service flow is obviously is the maximum rate of the flow. For example, for level of service B, the maximum flow rate for a given highway is 1100. It means that every situation is ideal. Every situation ideal. What was the ideal situation? If you remember from the last session, for example, some of the ideal condition was one lane width should be 12 feet. Okay, so 12 feet is the ideal situation. The clearance or the shoulder should be at least 6 foot. Okay, so and what other thing? We don't have if we don't have any heavy vehicle on the road, so this is also considered as an ideal condition. And whatever, what else, like train, if we have level train, so it means that it is ideal condition. But we never have ideal condition in outside, isn't it? In the real world, we are not facing with ideal condition, never ever. So MFS, the maximum service flow, is for maximum rate, maximum traffic rate in the ideal condition. So maximum service flow rate per lane is can be easily calculated with this equation. So the CJ is the capacity, okay, the capacity under the ideal condition. So we have only two value for this CJ. When if we mention that the speed is 60 or 70, so the C would be 2000. Otherwise is 1900. So we have only these two value for ideal capacity. This CJ stands for ideal capacity, the maximum capacity. Okay, so it is 2000 or 1900. Okay, so this value also can be found out in the table. Okay, so the I stand for one specific level of service. So when we are talking about the maximum service flow, the first question is for which level of service? For example, maximum service flow for level of service C. So we can come here and find out the maximum service flow for level of service C is 1550, and the V over C is 77%. Okay, so uh, this equation can be used frequently, but we never have, as I mentioned, we never have the ideal condition in the real world. So MSF, which is maximum service flow, must be have some adjustment to adjust it to the real world. It means that with some equivalent and with some factors here, as you can see, like FW or FP, there are factors that help us to adjust the ideal one, to the real world one, to the service flow rate. So definitely the service flow rate is lesser than the maximum service flow in the ideal situation. So these values, these factors usually are less than 1. For example, here is the factor for lane width. It means that when the lane width is less than 12, so we have to do some adjustment. For example, in some problem, the given data is like that the number of the lane for each direction is 2. So n is number of the lane for each direction. Remember, for each direction. For example, if in the problem, let's say maybe we just give you data some tricky. Like we say that 6-lane highway. So n is not 6. It is directional. N is equal to 3. It means that 3 lane for each direction. So n is 3, not 6, not total lanes for the whole highway. This n stands for directional lane, okay? So, for example, a highway with 4 lanes, it means that n equal to 2. The lane width is 11. So it means that the lane width is less than the ideal condition. So we have to find out when the lane width is 11 or 10 or 9, which are or less than the ideal one, which was 12. So this factor, we have to consider this factor to reduce the maximum service flow, right? So the other one is the factor for heavy vehicle, okay? This HV stands for heavy vehicle. And the last one is population. Population means that, for example, during the weekday, in the peak hour, we are facing usually with the commuters, isn't it? Like in the morning peak hour, we have a uniform traffic, which most of them are commuters, daily commuters, which they are facing or heading to their office, to their jobs, or like that. And the peak hour in the evening, again, we are facing with a uniform commuters. So, uh, otherwise, for example, in the weekends, but we are not facing with a uniform population. So, when we don't have a uniform population, we have to consider this one. As a matter of fact, between these three factor, only the heavy vehicle factor is the challenging one. These two is very easy. We use one table to find out this, and we use one table to find out this. But for this one, we use one equation and like 5 or 6 tables to calculate the factor for heavy vehicle. Okay, so if we just combine the equation 3-1 and equation 3-2, we will find out the equation 3-3. Okay, so service flow is the capacity for the ideal situation. So remember, we just mentioned we have only two value for this CJ. 2000 if the speed it was 70 or 60, okay, and otherwise 1900. Only two value. Most of the time we use 2000, okay, because given a speed is a given data, given information in the problem, and most of the time is 70. So most of the time we use 2000 for CJ. And also we have to find out this value from the table 3-1. We oversee for one specific level of service, number of the lane, and these three factor. All right. So for adjustment, okay, adjustment. When we say adjustment, we talk about these three factor. Okay. So let's go to the first one, FW. From this table, you can easily find out the FW. So in the problem, we usually talk about both side of the highway. It means in the both direction, okay, and both sides on the both sides. So we usually use the right side of the table, okay. In some, maybe some problems they give you more detail and make it more complicated, with which with maybe they mentioned that on the one side the lane width is like, for example, 12, and on the right side is 10. So it is more tricky. But here, let's say for easier one is like let's say that on both sides we have same condition. Okay, usually we are facing with both sides. So number of the lane also is important here. So when we say like we have a 4-lane freeway, we have you have to use the upper side of the table. When we say 6-lane, 8-lane, like that, so you have to use this part. Okay, so for example, in a 4-lane freeway, it means that we have 2 lanes for each direction, and for the both side the lane width is 10. Okay, so it is less than the ideal one. When the lane width in the problem is less than 12, you have to understand that you need the FW. You need a factor to reduce the maximum speed flow, service flow. Okay, and FW, this table easily you can find it out. So let's say the lane width is 10, and we don't have any shoulder, so the shoulder is 0. So we came here and we will find out that FW would be equal to 74%. Very easy. So the other one is the factor for heavy vehicle. As I mentioned, this one is the challenging one. So the hardest one is this one. Okay, we have different kind of heavy vehicles. We have trucks, we have bus, and we have RV. Okay, even for truck, we have 3 different trucks. We have light trucks, we have typical or normal trucks, and we have heavy trucks. Okay, so for all of them, we have different kind of tables. So, for example, in the final exam, if we mention we have light truck, okay, you have to go directly to the right to the light truck table. If we mention we have typical trucks or normal trucks, you have to go to the normal truck table. So this part is also very easy, but you have to make sure that you're selecting the correct table. Okay, so first of all, we need to find out the equivalent. What is equivalent? Equivalent is used for adjustment. Okay, we need 3 equivalent: ET, EB, and ER. ET stands for equivalent for trucks. EB stands for equivalent for bus, and ER stands for equivalent for RV. Okay, the other one is PT, PB, and PR. These are the percentage of the trucks. For example, in the problem, maybe they say that like this: we have 10% trucks. It means that for total traffic flow, 10% 10% of the total traffic flow is trucks, or we have 5% bus. So it means that from total traffic flow we have 5% bus. So PB would be equal to 5%. Okay, because they are definitely the given information in the problem: PT, PB, and PR. But ET, EB, and ER, definitely you have to find them out from the tables. Okay, we have different also kind of train. Okay, level train, rolling train, mountainous train. I'm sure that you already have this experience that when you are in, for example, a rolling train, it means that we are facing some grades, but the grade is not that much that the heavy vehicle can move, but in very slow motion. Okay, so when we are facing with the heavy vehicles on the road, you will see a slowness in the traffic flow. So you know that heavy vehicle is the reason for this slowness in the traffic flow. Okay, so we have the three different train. So in the level train, we don't consider any adjustment. In the rolling train, different, and the mountainous train also different. Okay, so these are also have different tables. Here is the first table. Okay, so the equivalent for extended general freeway segments. As I mentioned, we have three different trains. So the level one, it means that the grade is we have a very small grade, and the rolling and the mountainous. So for example, equivalent for trucks, ET, would be equal, for example, for rolling to 4. So ET is equal to 4, EB equal to 3, and ER equal to 3 also. So these levels, these trains also definitely are given information in the problem. So in the problem, we will give you this information that, for example, we are facing with rolling train. So in the rolling train, you know that you have to come to this column. Okay, so as I told you, we have to use different tables for calculating the equivalent. So I just mentioned that we have three different kind of tracks: typical one, or the normal one, and also the light one, and also the heavy one. So here also we have the weight in the pounds: 300, 100, 200. So 200 is the normal one, 100 is like light one, and the heavy one is 300. And we have also RV, and we have the bus. So when we mention that it is a typical one, you have to go to table 3, 4, or for example, when we are talking about the buses, we have to go to table 3.8. Okay, so also we have a equation here. So we can use this equation right after we find out the ET, ER, and EB. So as I mentioned to you, PT, PR, and PB are percentage, proportion. Okay, so they are given information in the problem. For example, we will mention that we have 10% truck, so the P is 10%, the PT is 10%. So they are given information, the P value, but E value, you have to figure out from the tables, different table we just show. Uh, we, uh, we will show you in the next slides. Okay, here is the first one. Okay, for example, definitely the number of the lane is important. Again, here in most of the table, number of the lane is important, so always remember the number of the lanes. For example, when we say we have a 4-lane freeway, or maybe we mentioned like we have two lane for each direction, so you have to use the left one. Or when we say 6 lane or 8 lane, you have to use the right side of the table. Okay, so for different grades and different lengths, you can find out different equivalents for track, but this one is for typical. So remember, as I mentioned, choosing the right and specific table is the most important things for calculating the factor for heavy vehicles. This table used for light trucks, exactly like previous one, and the other one is for heavy trucks. Okay, so it depends on the grade, specific grade, and the length. All right. For example, they are definitely given information. For example, if we mention that the grade is 2% and the length is like between 1.2 and 3.4 mile, so you know you have to come to this row, and it is a 2-lane. freeway, so you know that you have to use this side of the table, the left side. Okay, so in this row you can find it. Okay, very easy. And also here is percent. This one is also, as I told you, is given information. The PT or percentage of the track is here. For example, if we mention that we have 10% track, so you have to use this column. Very easy. So also here is for RV and the last one for the bus. So totally for the equivalent, we have at least five table. Three for trucks, normal trucks, light truck, and heavy truck. One for RV, and here is for the bus. So according to the grade, easily you can find out the EB for the bus. Okay, this table is exactly as same as this equation. Okay, you either can use this one or this table, no different, they are same. Okay, for example, if you from this table find out the ET for light truck is, for example, is stand for 4. ET is 4. Here is for ETEROE. Okay, it's 4. And then the percentage is 10%. Okay, so factor for heavy vehicle would be 77%. Or if you don't want to use this table, you can use this equation. But before you use this equation, you have to find out ET, ER, and EB. Okay, usually in the final exam, in the problems, we give you only one of them. And most of the time is drag. So this part of the equation, you don't need it. So you have to figure out the ET, and from ET you have to find out the FHV, factor for heavy vehicle, from this table. Very easy. And the last one is, if you remember, was for population, as I explained for you. So the adjustment for population is only in two categories. Is it on the weekday or is not on the weekday? Maybe in the final problem, we mentioned weekday. If we mention weekday, you know that you don't need this factor because it's equal in the weekday, it is equal to 1. Okay, so, or maybe we say commuter. So again, you don't need this factor because factor for population would be equal to 1. Otherwise, you have to use a value between this range. It depends on the situation also. It depends on the condition on the road and depends on your engineering judgment. Okay, we will discuss about this further, that which value is better, but whatever you choose here, the final answer would be almost same, specifically for designing the number of the length. So you have to just you just take the between, like 80% or 82%, 85%. Okay, so we just describe the analysis of level of service. Okay, but the question is, what is the application of this analysis? What is the application of these all tables, all these equations? What is the application? Actually, it has three applications. One is operational analysis. Operational analysis is like, we have already a freeway, okay, but we don't know what is the level of service, what is the maximum service flow, what is the service flow currently in this existing freeway, on the current highway or current freeway. we want to analyze the level of service. Okay, so this is one. The other one is design. In design, a forecast demand value is used in conjunction with known design standards for geometric features and desired level of service to compute the number of the lane required for a freeway section in the question. So, generally speaking, in the design part, we need to calculate the number of the lanes. Okay, the number of the lanes. And also in planning, we have to calculate the number of the lane. But in the planning, we usually face with different terms like AADT. Okay, AADT, or uh, other kind of the terms like uh, H DDHT. Okay, directional daily volume. So what data we need for operational analysis? We need traffic volume, we need PHF. If you don't remember PHF, please refer to the previous session slides, which is peak hour factor. Okay, because usually for analysis we talk about the peak hours. Okay, because the peak hours are critical, so we need a peak hour factor. The other equation which is very useful here in the first step, it is very important. In the first step, you have to convert all the volume to peak 15-minute flow rate. Okay, so for converting, you have to use this equation. So uh, SF, or service flow, which is desirable for us, we always use SF, is the V over PHF. Definitely, PHF would be given information in the final exam. Okay, we will give you the peak hour factor, because you can also calculate the peak hour factor, but this is a given information. And also the V, the actual hourly demand value. So when you divide V over PHF, you can calculate the service flow. So remember, if we give you volume, if we give you demand, you have to, like hourly demand, you have to calculate it to a peak 15-minute flow rate. We need the flow rate in the scale of 50 minutes. Here you can use this value to convert it. So this is the first step. The second step is, as I explained for you, you have to calculate all the factors. What was the factors? We had three factors: factor for lane width, factor for heavy vehicle, and factor for population. As I just mentioned, factor for lane is very easy. You can use one table to find out. Factor for population also very easy. You can use one table to find out the factor for population. And the challenging one was the factor for heavy vehicle. Okay, then you have to determine the MSF. But MSF is related to one specific level of service. So for finding out the level of service, or finding out the V over C, you can use this equation. Okay, very easy, very easy. So V over C is equal to service flow, which we calculated in the first step of the problem. Okay, divided by Cj. Do you remember the Cj? The Cj is the ideal capacity. We had only two value for Cj. 2000 and 1900. CJ only depends on the speed. So when in the problem say, for example, the speed is 70, so CJ is 2000. The n is the number of the lane and these three factor. So easily you can find out the V over C. And when you have the V over C with using the table 3.1, if you remember, table 3.1 was in the beginning of the year, table 3.1. Okay. Using this table, easily you can find out the level of service using the V over C. So when you calculate the V over C, you come here with the design speed, you can find the level of service. So it is not a very big challenge for you because easily you can calculate it. Okay, so where we went here, segment fragment design. Okay, before that, for the operational analysis, yes, here. So that's it for operational analysis. So you can find out what is the level of service actually. Okay, so if you want to go through other one is the design. As I mentioned, the design is for finding out what is required number of the lane. So you have to calculate the number of the lane in the design usually, of course, but you may face with the different just factors like DDHV, directional design over volume, directional design over volume, and other traffic specifications. Okay, so again, in the first step, we need to calculate the SF, service flow. You have in whatever you want to do, you have to first calculate the SF. Again, whatever value we gave you, if we gave you the hourly demand value, you have to divide it to PHF. If we gave you the directional design over volume, you have to again divide it to PHF to figure out to find out the SF, service flow. Okay, but here you have to consider something in the design. H2 standards, actually H2 standards is like the manual. They give you some suggestion. So for example, here they give you some suggestion for V over C ratio. For the urban area, they suggest that you use the V over C equal to 80%, and for rural area equal to 60%. Okay, so this V over C in the design, you can find it also from the table 3.1 as I just show you. Okay, because in the design you have to find out the number of the lane. So here is level of service is not the problem. Here in the design, level of service is given information. You see, it is exactly the same. But in the first part of the operational analysis, we want you to calculate the level of service for the current highway. So in the current highway, obviously we have the number of the lane. Okay, but in the design application, we don't know how many lanes we need, but we want a desired level of service. We want, for example, our desired level of service, for example, is C. So you have the level of service. You can go to table 3.1 and find V over C. Usually we use table 3.1, but also we have to consider these values. Always remember these two values. Very easy. V over C for urban 80%, for rural area 60%. So as I mentioned, the first step just convert all the volume to the SF. Why we do this? Because we need a 15 minutes rate, volume rate. So SF, first of all, SF. Then again, all the factors. Factor for lane width, factor for truck, heavy vehicles, I mean, and last is the factor for population. This is exactly the previous equation, but here we have to use n. So for finding out n is equal to service flow divided by Cj multiplied by V over C multiplied by FW multiplied by F for a heavy vehicle and a factor for population. So here also again, as a reminder, ideal capacity or CJ is equal to 2000 or 1900. It depends on the speed. If the speed, the given speed, design speed is 60 or 70, the capacity would be 2000. Otherwise, if the design speed was 50, the capacity would be equal to 1900. Okay, so the what is this V over C? The V over C, as I mentioned, the H2 suggests us for the urban area 80% and for the rural area only 60%. But we can also find this V over C from table 3.1, which was regarding to level of service, because again I emphasize that this one because in the design we have level of service. Level of service is a given data. Okay, so this three factor also very easy, we can find out from tables. Okay, so this table is values of the volume to capacity ratio for use in design. Actually it is exactly the same as the table 3.1. They just change the columns. So in the table 3.1 the first column was level of service, but here they bring the level of service to the third column. It is exactly the same one. They just twist it. So if we have the V over C or level of service, then we have the maximum service flow, we have the density, and we have the speed. So many useful information in one table. The last one is the planning. So planning also is like design, but the different is like we will face with the different kind of the terms like average annual daily traffic AADT. So maybe in the given information in the final exam would be like average annual daily traffic. When we give you average annual daily traffic, so we are talking about planning. Okay, so you have to first convert the average annual daily traffic to directional design over value. Okay, and then convert the directional design over the value to SF, and then use the SF for calculating the N. Very easy, exactly like the same one. And the last table is service flow rate per lane, SFL, for use in planning analysis. So when you find out when you find out that we are talking about the planning analysis, you can easily use this table. It divided to three different rows for level train, rolling train, and mountainous train. So all the train has a different level of service. So here you can easily find SFW. Okay, I just go through the first operational analysis, then I will ask you to do one example for the design and submitted through online spectrum. Okay, so we have a 4-lane urban freeway. So as you can see here, older, it means that it is operational because we have already one freeway. So it is not design and it is not planning. Very easy. Information is every word are some information. 4-lane, it means that we have 2 lanes for each direction. So what is the n? Here we can find out that. So according to this, n is 2. Okay, so the speed is 60. What you understand from the speed from 60? So Cj is equal to 2000, isn't it? And directional peak hour volume is 2100 vehicle per hour. So here they gave you the directional peak hour volume. So as I explained for you, what is the first step? We need SF. We don't need this one. We need in the 15 minutes peak volume. We don't need the hourly like that. So we have to convert this one to SF. Okay, so with 6% trucks, what is the 6? 6 here is percentage of the truck. So PT is 6%. And PHF is 95%. I told you PHF is always given data. The freeway has the 11 feet length, so you know that it is less than the ideal one. The ideal one was 12, so you need to calculate, you need to find out actually the FW from the table. So and immediately at the pavement edge, both roadsides on median. So here you give you two important information. When they say immediately after pavement, it means that we don't have shoulder. So the shoulder is 0, okay? And it's on the both side. If you remember in the table regarding to this information for lane width or FW, we need this information. Is it on the one side or both side? And how long is the shoulder? So you use this information to find out FW. Evaluate the level of service on the facility. So and determine how much additional traffic could be accommodated before reaching the capacity. All right, so let's do one by one. So what was the first step? I just mentioned that the first step is to convert whatever volume they gave you to SF. For converting the volume to SF, you have to divide the volume per hour to peak hour volume. Okay, so here is it. So you easily calculate the SF, which is equal to hourly volume divided by PHF. So here we got the SF. What we need to go for evaluating level of service, what we need? We need the V over C. If we have V over C in this formula, okay, if we calculate the V over C, we can find out the level of service from table 3.1. So you have already SF, we have CJ, which is 2000, we have N, which is 2. So we have to go through these 3 factors. Any information about population? No. When it is not information, they didn't give you any information about the population, you have to consider equal to 1. So we consider that it is weekdays. Okay. So this one is equal to 1. What is FW? For FW, you have to go to a table 3.3. Okay, table 3.3. You remember? This is table 3.4. Just show you here. No. Okay. Adjustment for the lane. Okay. So they give you that you don't have any shoulder. So the shoulder is 0. And they also mentioned that the situation are on the both sides. So you have to come to this part. And the lane width is 11. So what is the F for, what is the factor for the lane width? It is 79%. Isn't it? Very easy. So the shoulder was 0. We have the situation for both sides. And the lane width, they gave you 11. So you can find FW like 79%. Very easy. So come back to the problem. Coming back to problem. All right, here we go. So just we found it like here 79%. Okay, the other one, what you need here was FP for population, we consider as the one, and the only challenging one was for heavy vehicle. So but here is very easy. Why? Because they just mentioned that we have 6% trucks, only trucks. So easily you can find out the FHV from table 3.9. So when you have 6% trucks from table 3.9, so I don't show you here because we are running out of the time, but easily in the table 3.9 with 6% trucks, and ET for truck is 4. Okay, for rolling train, because here they mention it is the rolling train. Okay, so you can find it very easy, which was equal to 85%. So V over C what is equal to 82%. If you go to table 3.1, refer to table 3.1 by referring to table 3.1 here. Let me zoom in. So 81%. V over C is 81% or 82% if I don't mistake. So it is between C and D. So we have to consider as a level of service D. So the level of service for current highway is equal to D. All right. So here we just answer the first part of the question, which was we have to calculate the level of service. So level of service is D, which is expected to occur for V over C value in the range of 69% to 84%. Okay. So the second part of the problem was determine how much additional traffic could be accommodated before reaching the capacity. What is the capacity? When we are reaching the capacity, very easy. When the V over C is equal to 1, when V volume over the capacity is equal to 1, it means that we are reaching the maximum capacity. It is full. The highway is completely full. So how much is the rest one? According to figure 3.3 and 3.4 can be entered with effective V over C ratio, which is 82% to find approximate speed and density of the street. All right. So now we have to compare these two kind of capacity, comparing the density of 40 with LOS criteria on the table 3.1. Okay, so if we put here V over C equal to 1, and again calculate the SF, okay, again calculating the SF, how much would be the SF? So very easy, just during the peak hour value rate. Therefore, the here we can find out. I don't know is mentioned here or not. Yes, here we go. So I was talking about this one here. So when V over C is equal to 1, it means that we already reached the capacity. So when they ask how many additional traffic flow we reach to capacity, so it means that we have to um, consider V over C equal to 1. Then again calculate the SF. So the SF would be 2211. So different between the capacity, which we calculate in the first step, and the actual flow rate with the V over C equal to 1 is 2211. So different would be 475. Okay, you can leave the answer here because it's also complete, but you can also again convert it to a volume. Convert it to a volume. Remember, in the first step, we give you volume, you convert it to 15 minutes flow rate. Here we have the 50 minutes flow rate. We can convert it to volume only with multiply it with the PHF. So if you multiply with the PHF, which was 95%, you will reach 451 vehicle per hour can be accommodated in the peak hour without exceeding the capacity of the section. Right? So, okay, class. The other example is about the design, and the other one would be for the planning. So, but I stop here and I will give you the example and hopefully you can solve this problem about the design on yourself. Okay, so I put this one as a problem, and please, after just listening to this slides, to this video, please try to solve the problem yourself and put your answer in the spectrum. I will correct it. Okay, thank you very much for listening. See you next week. Thank you.